Hello everyone, my name is Zan Lu, and today we're going to talk about the legacy of Dijkstra, pioneering computer science and software engineering. So, as we all probably know already, Edgar W. Dijkstra was one of the most influential figures in the field of computer science and software engineering. Most of the people are still by nowadays deeply influenced by his extensive contributions and his foundational work in the algorithm known as the Dijkstra algorithms. I'll also talk about a little bit his programming languages and as well as his methodologies in some of the aspect of the software development. By examining his key achievements and also reenacting some of his famous algorithms, including the shortest path problem, we'll be able to see the relevance of Dijkstra's work in today's technology. So, first of all, let's talk about his algorithm. Dijkstra's algorithm is conceived by the Dutch computer scientist Dijkstra in 1956. It's widely used in the field of computer science for finding the shortest path between nodes in a graph. Which nowadays we all know that some of the map app, any technology that's like such as Google Maps, finding the shortest path from a point to the other, as well as uh, some also fields including like medication or like brain cognition. They all need the Dijkstra algorithm. And of course, the road networks is also part of it. So the algorithm works by initializing the starting node's distance to 0 and all other nodes' distances to infinity. It then repeatedly selects the node with the smallest tentative distance, exploring its unvisited neighbors and updates their distances if a shorter path is found. We're gonna talk about a little bit about his algorithm known as the ALGOL or LALGOL. It was instrumented by Dijkstra in the development of several key concepts, including the design and implementation of ALGOL 60, which is a high-level programming language that was pivotal in the advancement of structured programming. It introduces many concepts that are fundamental to modern programming, such as block structure and lexical scoping. His methodology in use of formal methods in software development, which is very crucial to people when it comes to emphasizing precision, correctness, and mathematical rigor. His software development methodology is usually referred as a structured programming, which is one of the key aspects is to eliminate the chaotic and error-prone practices during the early programming stage. We're going to talk about a lot about this, which I'm pretty sure most of people have already seen this before, which is find the shortest path from source to all vertices using his algorithm. This type of problem usually starts with a weighted graph and a source vertex in the graph. As you can see from the PowerPoint, it's to find the shortest path from the source to all the other vertices in the given graph. So how are we gonna tackle this type of problem using Dijkstra's algorithm? We'll usually find the shortest path from a source vertex to all other vertices using the algorithm to within these three steps: initializing, processing with the current vertex, and select next current vertex, and then repeat. For initialization, we'll create a set of all vertices. Let's call it V. We'll assign a tentative distance value to every vertex. We'll set the source vertex distance to 0 and all other vertices to infinity. We'll then set the source vertex as the current vertex. So if you see from the graph right here, let's say we select 0 as our starting vertex. We'll remember to create a set of all vertices first, of course, and then assign a tentative distance, the value to starting with 0. This is our source vertex. And then we set the source vertex as the current vertex. So right now, 0 is our current vertex. We then process the current vertex to consider all its unvisited neighbors. We'll calculate their tentative distances through the current vertex. We'll compare the newly calculated tentative distance to the current assigned value and assign the smaller one. After considering all the neighbors of the current vertex, we'll make sure that the current vertex is visited. A visited vertex will not be checked again. So right now we're at the current vertex is at 0. Following the process, we will calculate tentative distance to all the neighbors, which is 1 and 7. Our distance is 4 and 8, correspondingly. We'll compare the newly calculated tentative distance to the current assigned, which in this case is 4 smaller than 8. And then after considering all neighbors of the current vertex, we'll mark the current vertex as visited, so 0 is now visited. A visited vertex will not be checked again. We'll then select the next current vertex. We'll select the unvisited vertexes with the smallest tentative distance and set it as the new current vertex. So right now, since 4 is our smaller distance, we'll set 1 as our current vertex. Repeat the process until all the vertices are visited or the smallest tentative distance amount of unvisited vertices is infinity. So we'll do this again, starting with 1, with our being our current vertex, and then compared to our neighbors, we have 8 as our smaller one, so we'll definitely choose 2 as our next current vertex. Repeat until we visit all the vertices. So for this problem, we'll see that the final shortest path distance from the source vertex 0 to all other vertices are 0 to 0, 1 to 4, 2, 12, 3, 18, 4, 18, 5, 11, 6, 9, 7, 8, 8, 14. We'll be able to see that using his algorithm, we can tackle this type of problem easily. Whether you wanted to visit the shortest distance from a point to the other, or you just wanted to travel all the other points. Of course, now the modern technology that use mapped, in the road networks or mapping, they'll use a slightly advanced Dijkstra algorithm, including different layers of vertices, or if it's like a 3D, we will map it into a 3D vertices. But in general, they all come from the basic type of problem. Always come from the solution comes from the Dijkstra algorithm, and of course, there's still room to improve when it comes to finding the shortest path. And I believe that this is something that we can take more time to look into, and will be definitely it's a very interesting thing to look at. That's it for today about the Dijkstra algorithm, and thank you very much.